Yeah, good morning students. Today I am going to discuss about similar triangles. In that similar triangles, the concept is vertical angle bisector theorem. So similar triangles part 2. In that I am going to prove vertical angle bisector theorem. What does it state? Actually, why we should do this theorem? Because while doing numerical problems, we need to have a knowledge about this, otherwise we cannot do problems. So what does it state? Vertical angle bisector theorem. We know that B and C are the base angles. A and C are the base angles. Angle B is the vertical angle and BD is the bisector. Once again, A and C are base angles, BD is the bisector because it is dividing this angle into two equal halves. So in order to what does it state? The bisector of the vertical angle, that means BD, divides the bisector of the vertical angle divides the base AD by DC. The bisector of the vertical angle divides the base. It is dividing the base in the ratio of the other two sides. This is in the ratio of the other two sides. This is the base. The other two sides are AB and BC. Like that. So the bisector of the vertical angle divides the base in the ratio of the other two sides. So this is what we are going to prove. For this, we need to do construction. Draw CP parallel to BD or DB, anything. Draw CP parallel to DB such that BA is produced to meet at P. Such that AB is produced to meet at P. Right? Next, proof. Let angle ABD is equal to angle X. Angle DBC, this is also X, because it is given angle B is the bisector. Next, in order to prove this one, you need to know about two things. What is that? Is basic proportionality theorem as well as corresponding angles and alternate angles. What does basic proportionality theorem states? If a line is drawn parallel to one side of a triangle, then it will divide the other two sides in the same ratio. Now this is the whole triangle ACP, and this line AB is parallel to CP. So what is that? If a line is parallel to one side of a triangle, then it will divide this side is over, then it will divide the other two sides in the same ratio. That is, are you getting? Because in similar triangles, first we have proved that basic proportionality theorem and the converse of it. And for doing geometry is the easiest topic, easiest subject, provided you should know the basics of the previous classes perfectly. So now I am applying that BPT by BPT, basic proportionality theorem. What does it state? AD by BC is equal to AB by BP. AD by Y. Why I have written like that? Because simply write down DB is parallel to CP. Right? Now, case 2. What is case 2? It's very simple. Now this is x, so this is also x. Why? What type of angles are there? May I know what type of angles are there? They are alternate angles. Why? Because they are lying on either side of the transversal. So here CB is a transversal. Next, case 2, angle DBC is equal to angle C. Alternate angles. Next, angle ABD. This angle is equal to angle B. Why? Because you see here, this one, this one, this one and this one. One angle is lying exterior, one angle is lying interior. They are lying on the same side, so they are corresponding angles. But angle C and angle next, what is angle DBC? Here you have written clearly. DBC is x. ABD, that is also x. So that means x is equal to angle C, x is equal to angle P. X means some angle like that. So therefore angle C is equal to angle P. Let us come back once again. Here I applied angle, lines are parallel means alternate angles are equal, corresponding angles are equal, but these two angles are equal by doing certain equations here. So DBC is nothing but x, ABD is also x, therefore angle C is equal to angle P. Right? Now here you look at this diagram carefully. ACP, not ACP, BPC. It's not ACP. Now consider triangle BPC. BPC. What can you guess here? What type of triangle it is? Base angles are here also x, no? Angle C is equal to angle P. We have written here. So this is nothing but if base angles are equal, then it is isosceles triangle. Therefore, consider triangle BCP. Angle P is equal to angle C. Therefore, BP is equal to BC, because base angles are equal. Now mark this as 1. What is given? AD by DC. You write AD by DC as this is equal to AB by BP. AB also write as it is. What is BP? Is nothing but BC. BP is nothing but BC. So see here, AD by DC is equal to AB by BC. Very simple, students. It's very simple. Now once again I will recap what you have done. I did a line, I drew the line parallel to AD and also given bisectors. So this base angles are becoming equal. I want to consider this triangle, then these two sides are equal. This is by basic proportionality theorem. Just I replaced in place of BP, BC. Therefore, AD by DC is equal to like this. Go in an order way. We are starting from this side. AD by DC is equal to AB by BC. Like that. Hence the theorem. Next. Another theorem, which is the last one in similar triangles. After that, we'll be doing continuously theoretical problems as well as board problems in the next week. SSS condition. Similarity. What is state and proof? A side similarity. What does it state is, if the corresponding sides of a triangle are proportional, then the triangles are said to be similar. If the corresponding sides of one triangle are respectively proportional to the corresponding sides of another triangle, then the triangles are said to be similar. What does it mean is, AB by PQ is equal to AC by PR is equal to BC by QR, given if the what did I say just now? SSS property, SSS axiom is, if the corresponding sides of one triangle are respectively proportional to the corresponding sides of another triangle. That means AB, and for side AB, what is the corresponding side? PQ, AC, PR, BC, QR. That is given. Now what we have to prove? What we have to prove? Triangle ABC is similar to triangle PQR. Triangle ABC is similar to triangle PQR. So here we need a construction, that is, mark 2 points on this big triangle such that this length AB is equal to PD. Mark 2 points on triangle PQR such that AB is equal to PD and AC is equal to PE. So you write down all the steps. AB is equal to PD. Next, AC is equal to PE. Right? Mark 2 points. I have already written. Mark 2 points on big triangle such that this length is equal to this length, this length. Why? Because similar triangles, it is always possible. This small triangle, this is a big triangle. So therefore they are looking similar. Similarity. Now take this one. AB by mark this whole condition as 2. Mark this whole condition as 1. In place of AB, you can write PD by PQ, right, as it is. Next, in place of AC, you can write PE by PR from 1 and 2. In place of, this is AB, in place of AB, I can write PD. In place of AC, I can write PE. Now go back to this. PD by PQ. PD by PQ is equal to PE by PR. What is the converse of basic proportionality theorem? If a line divides the other two sides in the same ratio, then that line is parallel to the third side. If a line divides the other two sides in the same ratio, consider triangle PQR. CE is a line. This is a line now for this triangle. it divides the other two sides in the same ratio. See here, it is dividing. Therefore, DE is parallel to QR. Right? Now, if this is parallel to this one, what can you say about this angle? What type of angles are there? Are they alternate angles or they corresponding angles? What type of angles are they? They are not alternate angles, they are corresponding angles because they are lying on same side of transversal. One is exterior, one is interior. So therefore, angle D is equal to angle Q, angle E is equal to angle R because they are corresponding angles. Here you can write corresponding angles. And now consider triangle PDE and PQR. Next, consider triangle PDE and triangle PQR. For this triangle, small triangle and this big triangle, angle P is common angle because DPA is nothing but QPR. Next, angle D is equal to angle Q, angle E is equal to angle R. So, what can you say? Two triangles are there, their corresponding angles are equal. That means by using angle similarity, these two triangles are similar. Therefore, triangle PDE is equal to triangle PDE is similar to triangle PQR. Why it is like that? Because since angle P is equal to angle P, or you can write angle DPE is equal to angle QPR. Next, angle D is equal to angle Q, angle E is equal to angle R. Therefore, by angle similarity, right? Angle similarity, I have proved that this triangle is similar to this triangle. Now triangles are similar, that means their sides are proportional. Just consider this one. This all I am erasing, or else let us consider here. Therefore, PD by this length, PD by PQ is equal to, next, PD by PQ is equal to QR. This big triangle, QR by this one by D. I can write like this because the ratio is same, since these two triangles are similar. Now, clearly I will explain once again this, because since the two triangles are similar, I am taking the ratio. If I take the ratio will be same. So PD, PQ, the letters should coincide. Next, QR and D, last. This one, DE by QR. PD by PQ is equal to DE by QR. Just interchange this one because I want to make it as big one. So PQ by PD is equal to QR by DE. PQ, whole one I want to consider by PD, this one, and QR by B. Next, now come back to this PQ by PD. PQ by PD, this is PQ by PD. PQ by PD. What is given PD? What is given PQ? In place of PQ, what can I, in place of PD, I can write AB. QR you write is as it is. In place of DE, this is DE, QR. Just 1 minute, DE, QR. QR by DE, I'm sorry. In place of QR, what you can write? PQ by AB, PD I have written AB, and leave it like this, QR by DE. Just once again, since these two triangles are similar, I have written by these conditions are satisfying, therefore I want to take this length PD by PQ is nothing but DE, this last one, DE by QR, just I interchange reverse. Now what is given here? AB by PQ. This whole thing I am erasing, or else we will think right. What is given here? AB by PQ is equal to, I want to write this one as this one, BC by QR. Mark this as 1, 2, 3, mark this as 4. From 3 and 4, consider 3 and 4. Here what is given? AB by PQ is there, but here PQ by, just reverse it. This can be written as AB by PQ is equal to DE by QR. Now AB by PQ is equal to BC by QR. Now in place of AB by PQ, I can write DE by QR is equal to BC by QR. In place of AB by PQ, I can write DE by QR. That is what I have written. Now QR gets cancellation. DE is equal to BC. DE, this length, is equal to BC. Now already we have proved that this side is equal to this side, this side is equal to this side. Now we have proved that BC is equal to DE. So once again let me explain. Construction, what we have done is mark 2 points such that this side is equal to this side, this side is equal to this side, right? Next, consider triangle PQR. PQR. Since C is a line, next why we have written like this? Because AB is equal to PD given. In place of AB I have written PD. In place of AC I have written PE. Therefore, C, why it is a parallel line? Because the ratio, this line is dividing the other two sides in the same ratio. Therefore, line is parallel and corresponding angles are equal, and this angle is common, triangles are similar. This triangle is similar to this whole triangle. Next, I did some ratio because the triangles are similar. I can take the ratio of this PD by PQ is equal to something like that, DE by NQ, and I got like the answer like this. Now I am comparing given one with this condition. So I got DE is equal to BC. Therefore, what you can write is, what you can write, children? This triangle is congruent to this triangle. Why? Because in 7th class what you have learned, if the sides of one triangle are respectively equal to the sides of another triangle, then the two triangles are congruent. Therefore, triangle ABC is congruent to triangle PDE. That is, triangle ABC is similar to triangle PDE. Congruency means obviously it will be similar. Similar congruent triangles are always similar triangles, but similar triangles are not always congruency. Therefore, from this and this, triangle PDE, triangle PDE is similar to triangle PQR. Triangle ABC is similar to triangle PDE. PDE is nothing but triangle PQR. PQR. From clubbing these two, hence the theorem. So once again, triangle PDE is similar to triangle PDE is similar to triangle PQR. I have written like this. But triangle PDE is congruent to this one, or this is congruent to this one. That means they are having same shape and same size. So therefore, I am clubbing these two. Clubbing these two means if the triangles are congruent, means obviously they are similar. So this triangle is similar to this one. This triangle is congruent to this one means the triangles are similar. I am clubbing this and this, hence the theorem. So that's it, students. With this, theorems are completed. Vertical angle bisector theorem completed. Next time we will be doing similar triangles, numerical and theoretical problems. Thank you, students. Bye.